say when you do these problems, like when it says not to use a calculator, don't use a calculator. I can't really stop you from using a calculator on your homework, but when you see problems like this that say do without a calculator, know that when we have a quiz or a test, these would be the ones that you're not allowed to use a calculator on. So if you're using a calculator when you're not supposed to, then you're not really preparing for when we have a quiz or a test. So just be prepared for that. And right now, when you see the words without a calculator, that's like a big clue that that means use those special triangles. 19 through 24 yesterday said do without a calculator, and your answer was like find the sine of 30 degrees, and you drew the picture and you gave me the ratio. This is just going the other way. Like notice on this one, they tell us that the secant is 2, so what they want us to do is they want us to tell me what angle has a secant of 2. Here's what's super great right now. If you're using the special triangles, you only have 3 options. It could be a 30-degree angle, a 60-degree angle, or a 45-degree angle. So even if you have no clue how to do this, if you know you're using the special triangles, you have a 1 in 3 guess, like a 1 in 3 chance of guessing correctly, right? Right. So the idea is that you recognize, oh, it's one of those special angles. So let's draw them. 30, 60, 90. I hope that you realize that a property that you learned in geometry class is the smaller the angle, the smaller the side, the bigger the angle, the bigger the side. So if you know the numbers that go with this, 1, 2, square root of 3, the smallest number has to go with the smallest angle, so that's why 1 goes with 30. The largest number has to go across from the biggest angle, which is why your hypotenuse is always the biggest in a triangle, so that's 2 is the biggest number, and that's why the square root of 3 goes with 60, because square root of 3 is bigger than 1 but less than 2. And in a 45, 45, 90 triangle, notice my triangles like look the same even though one's 45, 45, 90 and one's 30, 60, 90. Number one rule that I teach my kids when I teach geometry is it doesn't matter what your picture looks like, it matters how you label it. So don't stress if your picture doesn't look that good. As long as you know in a 45, 45, 90 triangle, the sides are 1, and that makes the hypotenuse the square root of 2. So before we even go any further here, if these are my 2 triangles, which triangle do I have to be working with if I have a secant of 2? And we can go one step further if you're not there yet. I tend to like sine, cosine, and tangent better than I like secant, cosecant, and cotangent. So let's change it to one of the ones that are better thought of usually. Secant's reciprocal is which function? Cosine. So if the secant is 2, or 2 over 1, what's the cosine have to be? 1/2, you with me on that? So some people like to always change it to the sine, cosine, and tangent. They just aren't big fans of secant, cosecant, and cotangent. And don't we know that cosine is adjacent over hypotenuse? And so if you weren't sure which triangle you were now, which one you're in, this one has a hypotenuse of 2. That's not this triangle. Do you agree with me? Which means if you can get to this triangle, do you agree you're down to a 50-50 guess now? Like the answer is, which angle has a cosine of 1/2? It's got to be either 30 degrees or 60 degrees. And how do you know which one? You look at the triangle. If I take the cosine of 30 degrees, do I get 1/2 out of that? What's cosine? Adjacent over hypotenuse? That's not 1/2. What if I take the cosine of 60 degrees? It's adjacent over hypotenuse, which is 1/2. So my answer is theta is 60 degrees. If you had those triangles drawn at the top of your paper, you wouldn't have any work to show with this, right? The idea is there's not really much work to show. You got to know, 1, what's it asking? It's asking me what angle it is. And 2, I have to know my special triangles. Pay attention to the directions here. I want the value in degrees and in radians. Eventually, maybe you'll just know both of these in degrees and radians. But if you didn't, how do you change from degrees to radians again? pi over 180. So 60 over 180, that's going to reduce down to 3 on the bottom. So 60 degrees is always pi thirds. Kind of, sort of, maybe, vaguely with me on that? That's what it means by do without a calculator. What about this one? We could leave this as cotangent, but again, a lot of people aren't big fans of the reciprocal functions, so let's change it. If the cotangent is 1, what's the tangent going to be? Still just 1, right? 1 over 1 is 1 over 1. Tangent is, what's the ratio for tangent? Really, that's like 1 over 1 right now. Which triangle do you have to be in if the opposite and the adjacent side are both 1? So what's my angle have to be? 45 degrees. Again, could you have figured that out without writing any work if you had your triangles up there? Yes, because the only one it could be would be 45 degrees. Again, you could change that to radians. Pi over 180, 45 goes into 180 4 times, so that is pi force. So without a calculator, use your triangles, figure out which one it is. It's either 30, 60, or 45 right now. Questions about that? I think the plan is to have a quiz next Tuesday. So that means by Tuesday of next week, you've got to be able to reproduce those 2 triangles from memory. Okay, so if you have no clue right now, you might want to kind of look over those this weekend. The other part of this is I do want you to be able to use a calculator, because unless it's a special angle, like 30, 60, or 45, then you have to use a calculator. And so if you don't have a calculator with you, I want you to have one. Who needs a calculator? Ready? Okay. And when we take our test, there will be questions like this, because I want to know that you can use your calculator correctly. Anyone else need a calculator? So notice it says, now use a calculator to find the value in degrees and radians. So first of all, before we start typing in our calculator, yesterday they told you to find the cosine or whatever of a specific angle. Find the cosine of 15 degrees, and you would type in cosine 15, and you got a number like this. Now we're going backwards, so we have to think about, we want to know what beta is. So we have to think about how to get rid of cosine. And some people might say, well, let's divide by cosine, but this is not multiplication. Yes? Okay, I don't really need, yes, I just need to sign her paper. So do you have an office person today? Oh my goodness. Can she come down here, or is that breaking the rules? Okay, thanks. Bye. Sawyer Arnold didn't fill out he didn't get any letters of recommendation for that, Putnam County Foundation scholarship that's due today. So Becky Arnold's in the office right now, filling out paperwork so that I can sign his letter of recommendation. Nothing like last minute, right? But I can't go down there. I don't have time for that. What if I said 4x equals 7? How would you get x by itself? And we would get x equals 7 over 4. Why do we divide by 4? Like, that's how we get x by itself. But why do we divide by 4 when it's 4 times x? Because it's multiplication, and division is what to multiplication? It's inverse. It's its inverse. The inverse of addition is subtraction. The inverse of squaring something is square rooting something. The inverse of cubing something is cube rooting something. Yes? We need to do the inverse of cosine, and just be very careful. Inverse and reciprocal are 2 different things. So secant is cosine's reciprocal, It's not cosine's inverse. You remember that this is how we show a function's inverse, f negative 1 of x? So that button on your calculator, that's cosine negative 1, that is the inverse of cosine. So to get rid of cosine, you do inverse cosine, and you put 0.9848. And whatever mode you're in, whether you're in degrees or radians, when you type that in your calculator, it'll give you the answer in that mode because you're finding what angle that is. And notice the direction was both. So for me, instead of doing the conversion, I could do it twice with the calculator. So if I'm in degrees first, I could hit inverse cosine of 0.9848. And in degrees, you should get, it's really almost 10 degrees, but I'm going to go to 3 decimals just so I can show you that it's not exactly 10 degrees. You should get like 10.003 degrees. And I also want that in radians, so I could multiply by pi over 180, or you can just change your calculator to radians. And on my calculator, it just keeps that same problem, and you just hit enter again, and it's way easier than doing a conversion. So what is about 10 degrees in radians? It should be about 175 radians. Did you get that or not get that? Anybody need calculator help? If you're good with that, go ahead and try for sine. So just know that the negative 1 is what you do when you're solving for an angle. So you're in, like that's radians, that's right. So to get degrees, you have to change the degree one. So that's right, that's part of the answer. You have to give it in both degrees and radians. Anyone else need calculator help? So this one we're going to do inverse sine at 0.8746. And again, you want both radians and degrees. So since I'm already in radians, I'm just going to do that one first this time. 0.8746. Or in degrees, like 60.998 degrees. They're pretty close to 61 degrees. So again, it's really important that you know how to do the different things on your calculator and which buttons to use. So make sure you're checking those answers in the back of the book. Questions about that? What else can we do with trig functions? Well, we can actually solve some story problems or solve for some missing sides and angles. So I got 2 more examples here, but they're not so bad to do. This lovely log cabin I drew. You don't even really need to draw that on your paper. Just It says a 10-foot ladder leans against the side of a house and makes a 60-degree angle with the ground. How far up the house does that ladder reach? Because you never know when you want to know if the ladder's going to reach and you don't have a tape measure. You can do a little trig function. So I'm just going to draw my lovely ladder here against the house. And it's 10 feet. And we're assuming that the house makes a right angle with the ground because hopefully your house is built so that it makes a right angle. Because remember that this only works for right angles. If you didn't want to draw this, like you could just take this picture and move it like this, right? If that could take a picture. The lovely right angle I drew. And it makes a 60-degree angle with the ground. So do you agree that that's down here is 60 degrees? And I want to know how far up the house it reaches. So I'm looking for this part right here. And this is actually a 30, 60, 90 triangle, which means we could kind of use those ratios if we wanted to. But a lot of the problems I give you aren't going to be special angles. So I'm going to show you the trig way of doing it And then if you want to use the special triangles, if it's a special angle, you can. So the idea is we can use trig to help us solve for unknown sides of a triangle. So if I know this is 60 degrees, and I'm looking for this side of the triangle, and I know this is 10, what trig function does it make sense that I would use to relate all those to each other? Which side is this compared to 60? This is the, and this is the hypotenuse. So which sine, you can use the reciprocal if you want, but could I say the sine of 60 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 10? Everybody with me on where I'm getting that? I'm just using the ratio that sine is opposite over hypotenuse. And we've just made a little math problem here. I want to solve for x, so what would I do to solve for x? Yeah, I'm just going to undo dividing by 10. So I'm going to multiply by 10. And you can just type that in your calculator. If you have one of those fancy calculators that I call a cheating calculator, when you type this in your calculator, it'll give it to you with the radical in it. But most of us unfancy people will just get a decimal. Make sure you're in degree mode, though, because you're typing degrees in, right? 60 degrees is very different than 60 radians, which hopefully the answer would tell you if you're in the wrong mode. But if you get a decimal form here, we would get about 8.66 feet. That's how far that ladder would reach up the side of the house. Questions about that? So does the picture make sense to you?
Yeah, it makes sense.
So whatever, like, you could have used another angle, but I always just take the angle that they give me and think about what you have. This is the opposite side of 60, and this is the hypotenuse. So just always think about which trig function you can use of the sides that you know and the sides that you want. So since this is opposite over hypotenuse, I said the sine of 60 equals the opposite side, which is x, over the hypotenuse, which is 10.
Okay.
You could have set up, like, you could have also said, if this is 60, do you know this is 30? Could you have said the cosine of 30 degrees would be adjacent over hypotenuse, and you would have another problem, and when you solved it, you get the same answer. So it's as long as you pick an angle and you set up the right trig function, you're going to get the same answer. Does that make sense a little bit? All right, so one more thing. Sometimes it's going to make you solve a triangle. And solve a triangle means find all the sides and find all the angles. So step one on this, after you write it down, see if you can find the missing angle. you find the angle that's missing in a triangle?
Yes.
Doesn't a triangle add up to 180 degrees? Like, no trig involved here. A triangle's angles add up to 180 degrees. If it's a right triangle, doesn't that mean these two have to add up to 90 as well? So you could take 90 minus 68, or you could take 180 minus 68 minus 90. So I think that one's,
We dismiss the lip sync participants, the dance team members, the band, and the cheerleaders.
Homework
at
is
this
on your
time.
assignment sheet.
And once again, I want to encourage the student body to come to the ball game tonight. Come early for the girls'
Okay,
game,
just for what,
stay
me?
for the boys'
For
game,
ours?
and the dance.
Because I'm not
And
there.
Mr. Burgess has an announcement here.
Normally, we call the
The
sign
first
across the
16
side
high
of those.
school or middle school students who come to Mr. Akers' room after school will get a red football jersey to wear in the cheer block tonight at the game. The first 60
Football jersey?
high school or middle school students after the pep session who come to Mr. Akers' room, that's right across from the band room, after school tonight will get a red football jersey to wear in the cheer block at tonight's game. So that's a great thing there. Thank you.
At the end of this hour. This is my last example, I promise. It's not. So, when they ask you to solve a triangle, there'll always be three things missing. Usually it's one angle and two sides. So the angle part, all you gotta do is subtract 90 minus 68 and you get 22 degrees. The other two parts that are missing are the sides, and that's where you have to use some trigonometry. There are many ways you can solve this. As long as you use the ratios correctly, you're going to get the right answer. So let's solve for A first. And you can use whichever angle that you want. You could use 68 degrees, you could use 22 degrees. But you have to use the one that they give you. So notice that this is the hypotenuse. So what do you want to use, 68 or 22? It doesn't matter. If you use 68 degrees, how does A compare to 68? Is it the opposite, the adjacent, the hypotenuse? So if we're using 68, this is the adjacent and this is the hypotenuse. So what trig function would we use? What trig function is adjacent and hypotenuse? Cosine. So could I say the cosine of 68 degrees is A over 25? You could have also used 22, but what does A compare to 22? It's the opposite. So you'd have to use sine of 22 degrees, and you would get the same answer. So it's not wrong as long as you use the right trig function with the right ratio. And then all you got to do to solve this is multiply by 25. And you get 25. Make sure you're in degree mode. Cosine of 68 degrees. And you get that A is about 9.37 units. Talking about the side of a triangle there. So we're not in degrees, we're in like whatever units it happen to be. Now we know two sides of the triangle. Could we do Pythagorean theorem to find the third side? Definitely. Could you use trig again to find the third side? I like trig because I feel like this I can do much faster than squaring and square rooting and subtracting stuff over. But it's not wrong to use Pythagorean theorem. But for me, let's just stick with 68 degrees. If I use 68 degrees and I use B, how does B compare to 68 degrees? It's the opposite, and I'm still going to use hypotenuse here. So could I say that the sine of 68 degrees is B over 25? You could use 22 degrees also, as long as you set up the right trig function. And again, we're just going to multiply by 25. Should B be bigger than A or smaller than A? Should B be bigger than 25 or smaller than 25? So that's kind of a way to see if you did this right. I got that B was about 23.18 units. We'll do a lot more with applications of this later, but this is just to kind of show you why we do right triangle trig, because you can solve triangles for missing sides and or angles. Okay? Big thing I want you to focus on is knowing those special triangles without a calculator. Okay? Look at that. This is like the fastest I've ever been done, and still I lost class. Oh, we're just going to get that. 4-2 day 2. If you don't have day 1 done, make sure you work on that. We are having, plan to have a homework quiz on Monday, so, things could always change. But the plan is get your homework done. Benjamin, homework. And you actually have 15 minutes in here, so you might as well get a good start on this. And if you have questions still from yesterday, I can help you with them.